AND concept. What do you mean by AND? Generally, people are calling some people are calling AND, some people are calling MapReducing 2. Anything is fine. Both are similar. Why MapReducing 2 is came into the picture? What is the drawback of MapReducing 1? What is the advantage of MapReducing 2? Why people are upgrading? And nowadays, recently, few months back onwards, now also I'm upgrading. Now we are moving MapReducing 2 to Spark. Again, a new concept. Now we are not in Spark, we are in MapReducing 2. What is the drawback of MapReducing 1? We are in the big data world. People are using number of data nodes. People are using hundreds of. See, if you have 10 data nodes, 5 data nodes, still those guys are using MapReducing 1 only. But if you feel like a real advantage of MapReducing 2 is if you go ahead with the more than hundreds of data nodes. If you go ahead with the more than hundreds of data nodes, then you are identifying the difference between MapReducing 1 and 2. Otherwise, the performance-wise, accordingly, both are similar in general clusters. If you have general cluster, both the clusters performance similar. If you want to feel like a real advantage of MapReducing 2, go ahead with the big nodes. Same concept is there. For very large clusters in the region, maybe the 4,000 data nodes, more than 4,000 data nodes, okay, is there, and we are storing that much volume of data only. That much volume of data only in our data nodes. Imagine like a petabytes or zettabytes of the data. Those data I want to process it. I want to process those data. As a developer, I submit the query. As a developer, I submit the query. What happened? How to process the data? Yes. Now in in MapReducing 1, we know first job tracker, respond, calling submit method, assign ID, almost like 10 steps is there. But in MapReducing 2, we don't have 10 steps. We have just like a 3 to 4 steps only. What is this 3 to 4 steps? First of all, the terminology also is different. In MapReducing 1, we have job tracker, task tracker is there. Okay. In job tracker, MapReducing 1, we have job tracker, task tracker, and name node, date nodes is there. But in our AND concept, we have instead of job tracker and task tracker, we have resource manager is there. We are calling a resource manager. Resource manager means the combination of job tracker and task tracker. And node manager is there. Node manager is a combination of data node and name node. Data node and name node we call a node manager, and the resource manager is like a job tracker and task tracker. Here, this resource manager take the responsibility to submit the job. This resource manager will coordinate the allocation of the computer resources of all the clusters. Okay, and this resource manager will handle all feature. The 10 steps is a job tracker, task tracker, assignments is ID, everything. Nowadays, not like that one. It's not required to take the metadata, everything. Everything is available. See, previously, if any task tracker is failed, first task tracker want to send the information to job tracker. Yes, so and so data node is failed. Then only job tracker knows. Otherwise, job tracker don't know. Even in case if data node fails, also task tracker sending fails to data nodes. If data node is failed, task tracker sending the information. If data node fails, task tracker fail to send the signal. Even if task tracker also fails, then task tracker fail to send the signal. You're getting what I'm trying to say? I'm trying to conveying the difference between both the performance, where the performance difference is coming, internal performance only. Task tracker generally sending the signals, data node signals, to find the health condition of the data nodes. Yes, if data node fails, task tracker not sending any signal, right? Even if task tracker also fails, that time also task tracker not sending any signal, right? Then we want to identifying where is the problem. Is a problem in the data node or a problem in the task tracker? Then only we knows, right? If the data is a huge volume of data, complete this approach is a time-taking process. Where in the big data, we have thousands of data nodes, thousands of data files are available in our data nodes. Then all this 10 steps approach is the time taking process. This only every time I want to follow this complete procedure, it's taking time to process the data. That's where MapReducing 2 came into the picture. Now, by using MapReducing, not required to follow all the steps. In the resource manager have already information. Resource manager only one mission. That resource manager every time taking care of this job information, health monitoring, everything. Then if I submit a job, immediately the job client, if you submit one, the job tracker as resource manager, already information is available. Calling a job submit method, already heartbeat, everything is available. Then finally find out the jobs, find out the date nodes, directly submit the jobs into date nodes. Not required. Previously job tracker send the jobs to task tracker, then task tracker submit the jobs into so and so date nodes. But here only one mission is there. That mission is like a resource manager. That resource manager only taking care here. Okay, same points is there here also. The client which submit the mapping job, then immediately the add resource manager will coordinate all allocation of the computer resources on the cluster. Where is my data is available? Immediately the resource manager will coordinate to all the resources. The add node manager which launch the job, which launch and monitor the compute containers missions on the clusters. Okay, and the MapReduce application master which coordinates the tasks running MapReducing jobs, the applications masters and MapReducing tasks. Everything will taken care of this node manager and resource manager. Okay, see that I'm giving the overview, conclusion from ADN and Mapper1 and Mapper2. As a Hive developer, as a Pig developer, as a front-end developer, we don't know the difference between. Don't know difference between means the framework will taking care. Okay. Okay. But if you want to see the difference between both the two, if you have the huge volume of data, okay, job submission time, job process time, okay, you get the feel of the real difference. Huge volume of data, Mapper1 give the bad performance, it takes some extra time. Mapper2 take less time. So small volume of data, both at the same time, similar time only. The reason is Mapper1 we have job tracker, task tracker, name node, date nodes, some procedure is there. That's why taking more time. Every time I want to follow the same procedure, that's why taking more time. But Mapper2 instead of job tracker and task tracker, name node and date nodes, we have resource manager, road managers. This managers taking care. Internally, this framework, this nodes manager, node manager and resource manager will taking care to submit the jobs. One job submit completed, then our framework execution is similar again. First mappers is there, then reducers is there. Mappers read the data from the data node. Reducers take the output from the mapper output. Mapper output take the reducer input, give the output. That is common again. That is the Mapper1 and Mapper2. Again, few more important points is there. I want to tell you regarding MapReducing. If we submit the jobs, internal schedulers are available, like a preferred schedulers, fair schedulers, capacity schedulers. Okay, generally people are scheduling internally. For scheduler is there. By using preferred scheduler, we are going to schedule our jobs. And even though failures also, there are major three types of failures is there in our MapReducing concept. Three types of failures. Okay, namely task failure, task tracker failure, job tracker failure. In our MapReduce 1. Task failure, task tracker failure, job tracker failure. Yes, these are major three types of failures. The first one is the task failure. Yes, usually this is the happen when the user code on the map, if any logic error in our code, that time this type of failure will happen. In map reducing, if you submit any high query, big queries also, there are three types of failures happen generally. Task failure, task tracker failure, job tracker failure. Task failure means this failure will be happen whenever is there any problem in our code, that time this failure happen, task failure. And task tracker failure. What is the task tracker failure? Yes, the task tracker failure is if the job tracker will notice the task tracker stop sending heartbeat. Okay, that time if job tracker noticed it, there is no send information from the task tracker, signals from the information from the task trackers. That means that time we are identifying that is a task tracker failure. The solution for first task failure is we want to resolve our code problem. And solution for task failure is we want to identifying either the death note problem or task tracker problem. Then we're identifying the problem, we resolve it. And the third one is the job tracker failure. Job tracker failure is, yes, the failure of the job tracker is the most serious issue because only one job tracker is there. If my job tracker is failed, there is no response from job tracker. Entire cluster, entire running process will be down. So immediately we want to resolve the task tracker failure, job tracker failures. So when we are running the data, these are three types of failures happen. Task failure, task tracker failure, job tracker failure. Depends on the failure, we are going to resolve issues. Okay. And finally, fourth one is there. Fourth type of failure, that is name node failure. That is a very serious issue. It's not happened as of now, any cluster. If it is your name node failures, complete cluster will be down. There is a fourth type of failure also, chances is available. Okay. So friends, that is the map reading concept.